We're going to talk about application of vectors today. We're applying vectors to word problems. So vectors can be used to represent any quantity that has magnitude and direction. So most commonly, something like that has a force. Velocity, weight, because it has gravity. These are the type of things that are represented with vectors. You probably will see problems similar to this when you take physics. So let's start with an easy problem. We have an airplane that flies due south 250 miles. So down 250. And then it's going to go due east 125 miles. What is the plane's distance and bearing from its starting point? So we need to calculate the resultant vector. Okay, so this is a distance problem. Okay, so we can't, I'm sorry. This is the bearing, right? It's the angle. That's what it means by bearing, is the angle. So the first thing we want to do is we want to figure out what that distance is. Well, we can do r equals the square root of x squared plus y squared. So 250 squared plus 125 squared, and then square root it. We get approximately 279.5 miles. So that's its distance. However, now we want to know, well, what is its bearing? What is the degree? Well, notice how we have a triangle, a right triangle, which means we can use our trig. So this angle right here inside the triangle, we can use trig. Tangent of this angle, okay, tangent of this angle is 125 over 25. So we use our inverse function. So tan inverse 125 over 250. Make sure you're in radians. You should get 0.5. However, you should get 26.6 degrees. Oh, actually, I'm sorry, they actually went to degrees. Let's go to degrees. So 26.6 degrees. But that tells us this angle inside the triangle. And we want to know the bearing from the starting point. But we know that this entire line is 180. So if this entire line is 180 and alpha is 26.6, we just have to do 180 minus alpha, or 180 minus 26.6, and we get our bearing of 153.4 degrees. Let's do another example. We have a river that's going south, and then a boat crosses that river upstream at a bearing of 60 degrees and at a speed of 30 knots. The speed of the current is 50 knots. So we want to know what is the bearing and velocity of the boat as measured from the ground. So if we have vectors that have forces, and if we draw them back to back, they form a polygon. So here's our first vector, the 30 degree, and then here's the next one, which is 10. So remember, the 30 was at a bearing of 60. And there's the 10. So we want to figure out this distance here with that bearing. So we want this bearing here from the initial to here. So first things first, let's get our r, okay? So we have r squared equals 30 squared plus 20 squared, plus 10 squared minus 2 times 30 times 10 cosine of 60. So you're like, whoa, where did that 2 times 30 times 10 cosine of 60 come in? Well, we need to subtract this triangle here, this little piece here, right? Because here's this, the 30 squared, and here's this, the 10 squared, but we don't want this piece. We don't want this piece right here. Okay, so we get approximately 26.5 knots. So now what about our bearing? Well, now we can use sine of alpha. So here, over 10 is sine of 60 over 26.5, which is what we had calculated, right? So this is a proportion, so we cross multiply and divide. And so we solve for alpha and we get 19.1 degrees. However, we don't want that, we want our bearing. So our bearing is 60 and this piece, so 60 plus 19.1, which is 79.1 degrees. All right, so we have a pilot who plots his course from one city to another, and it is 65 degrees. We have 40 miles per hour at 300 degrees, and we need to know what compass heading and airspeed should he fly if he wants to have a speed of 350 miles per hour to compensate for that wind that's coming at 40 miles per hour from 300 degrees. So here's 65, here's our 65 degrees, here's Fernwood, and here's Glendale, right? And we went 350 miles per hour. However, we have a wind of 300 So the chains are exactly the same. They're both at 45 degrees. We need to know what force does each chain exert. So if we're thinking about physics, we have this chain that's pulling at an angle this way, 45. And then we have this chain that's going this way at 45 with the force going that way. But then we also have the force of the weight, which is 10 pounds going down. This is a little bit of geometry. If this is 45 and this is 45, that's 90, leaving another 90 here, which means that that's a right angle right there. That's useful because now we have some triangles. So here's the weight, and this is a 45-degree angle right here. The whole thing is 90, but this half of it is 45. So that means we have x on this side, a force of x, and we have a force of x here. So since this is a 90-degree angle, we have x squared plus x squared equals 10 squared. X is going to be approximately 7.07 pounds. All right, we have a 20-pound box, and it's on a ramp, and the ramp is 30 degrees. It has a force up the ramp that's called friction, okay? And then we have normal force as well. The ramp has something that's called normal force. And we want to know what is the magnitude of this normal force. So normal force is here. Okay, we have the force of the weight going down. And this is, since the ramp is 30 degrees, that means this is 60 degrees here, which is useful because we know since that's 20 and then this angle is 30 and this angle is 60, all we have to do is figure out cosine 30 degrees equals x over 20. We just have to figure out this side here. So x is 20 cosine 30, which we get 17.32 pounds. All right, go ahead and attempt number 2. And if you need help, make sure that you ask me, and I will be glad to help you with number 2 if you need it.